5-axis work. Okay, now that we finished the 5-axis work, we're going to move into doing op number 2, which is the 3-axis work. I'm going to hide the toolpath for the 5-axis work. Remember to reference my guide for how to post-process this. And you might run it on the UMC 750, you might run it on the VF2. For the purpose of the assignment of uploading in Canvas, it doesn't matter which post you use, but when we actually run it in the shop, you're going to need to run the right type of code for the right machine. Okay, so now we're going to make another setup. And first, we're going to expand our models, and we're going to hide the TRT setup. And we're going to make the vise we're using visible. And let's rotate the model in an orientation where we'd be looking at the part in the vise. Okay, so what we need to do on this side is we're going to create a new setup, and that setup's going to take the stock from the previous operation. Now in reality it's all milled away below this plane, but what we're taking off is this dovetail on top. So, but I would not suggest that this is where our origin is going to be. I would suggest our origin is going to be placed on the same point we used to assemble this model. So we need to go back and we need to go to Sketches, and we need to make that sketch that we hid visible again so this point exists. Okay, so we're going to use a stop and a 1, 2, 3 block to set our origin to this face, machined face. Okay, so what we're going to do is we're going to do X and Z axis. We're going to select on the top of our part, so Z should be facing up, X should be pointing to the right. Let's go ahead and pick on something that's in correct action in X just to make sure, and flip it. And then we're going to go to, from not a box point, but a selected point, and we're going to pick the point we created in our sketch. So this will put our origin at the top of the parallels, left of the machined edge of the part. So our stop can contact that, and it can be well below all the machining we're doing above. Okay, next operation, we're going to go to the stock tab. It's from previous. We're going to go to post process. We're going to call this a 7315-2, which is the second operation. We're doing op 2, which is 3-axis work. And we're going to use work coordinate system 1 because we're going back to our traditional vise, G54. And we'll hit OK. Yep. And it looks like it's asking for me to select the model of the part. Not sure why. Somehow we lost that. Go to stock, post process, and OK. We're going to change the name of this to op 2, and then in parentheses 3-axis. So edit notes 1, use 1 and 5/8 tall parallels. Let's actually make that note 2. Note 1 is going to be WCS origin, WCS G54 origin, XYZ origin, left back of machined part, Z D0 top of parallels. First, we're going to do a contour around the part just to make sure that our facing isn't taking off too much material. So what we're going to do is we're going to do a 2D contour. We're going to use from our library the 1/4 inch end mill. We're going to keep defaults, feeds, and speeds. We're going to go to the geometry tab. And we're going to select the outside profile of our part. On the heights tab, we're going to go from stock top. And we're going to cut to, and we're going to use stock top as the model heights. And we're not going to go to selected contours, we're going to go to model top. Okay, so it's going to buzz around the outside to model top. We're going to go to the next tab. We're going to go to wear compensation. We're going to select roughing passes. We're going to select multiple depths. Okay, so on roughing passes, we're going to do 1.125. Other boxes will be at default. On multiple depths, we're going to do 0.125 as well. We're not going to do any finishing passes in Z. We are going to finish only at final depth. We are going to use even step downs. We're going to select stock to leave. We're going to leave radial 10 thousandths, but we're going to leave none on axial. We're going to go up to the linking tab. We're going to keep the tool down, and we're going to leave everything else pretty much at default. Is it okay? Okay, so we're going to be lapping around the outside. We got to be careful because it is coming pretty close to the vice jaw. Make sure you have the right size parallels in. And we're machining around the outside edge, leaving 10 thousandths of extra stops so we don't gouge into any finished surfaces that are already made. We're going to do a facing operation with the same cutter. We could use a 1/2 inch end mill. We're not hanging on to a whole lot here, so we don't want to put too much torque on the part and risk pulling it out of the vise. So we're going to go to facing. We use the same 1/4 inch end mill. Same feeds and speeds. We're going to go to the geometry tab. We're going to validate when yes, we want that orange profile that's outside of the stock. On our heights tab, we're going to go stock top, and stock top is fine. We're going to machine down to model top. That's fine. We're going to go to passes tab. And we're going to do a 0.126 pass extension. Our step over is going to be 0.2. Our maximum step down is going to be, we're going to check multiple depths. Our maximum step down is going to be 0.06. We're going to do a finish step. That finish step is going to be 10 thousandths. We're going to use even step downs. No stock to leave. We're going to go to the linking tab. On the linking tab, we're going to get rid of our vertical lead-in radius and leave everything else at default. We're going to hit OK. Okay, and our last operation is to do the deburring on the back. So we're going to go to 2D chamfer. We're going to select our chamfer tool from our library. Keep the defaults, feeds, and feeds. We're going to go to geometry, and we're going to select the rim of our chamfer. We go to the heights tab. We'll change all this to model top. We're going to go to the next tab. We're going to leave that at default. We're going to check the smoothing. And then we're going to go to the linking tab. And we'll leave all that at default. And hit OK. Now we need to scrutinize this, make sure that, yes, it's not going to hit our vice jaw. We should have clearance. So if we're going from this edge and we're offsetting 40 thousandths, and we have 55 thousandths, so we just barely have enough clearance for that chamfer mill to lap around that and not hit the steel job. Okay, that's it. We finished programming this part.